Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P2720, refers to a low input signal in the automatic transmission, AT, clutch pressure control solenoid valve D. This solenoid plays a critical role in regulating pressure to ensure proper shifting of gears within the transmission. If this solenoid does not receive adequate electrical input, it can prevent the transmission from shifting into second or fifth gear as part of a fail-safe function, causing potential driving issues. The solenoid is commonly located within the transmission assembly, and issues typically arise from electrical circuit problems rather than mechanical failure. Therefore, diagnosing this DTC primarily involves checking various electrical components and connections related to the solenoid and the powertrain control module, PCM. Proper troubleshooting can help identify whether the issue is with the solenoid, wiring, or the PCM itself. The AT clutch pressure control solenoid valve D is responsible for managing the hydraulic pressure applied to the transmission, which ensures seamless gear shifting. This valve is integrated into the valve body assembly of the transmission, making it crucial for optimal performance. When the solenoid receives electrical signals from the PCM, it adapts the pressure based on real-time driving conditions. Signs of failure can lead to erratic shifting or total inability to shift into certain gears. It's essential to note that the function of the solenoid is electrical. Thus, mechanical problems within the transmission typically do not cause DTC P2720. A careful inspection of the solenoid and its electrical connections is necessary to pinpoint the specific cause of the low input signal indicated by this code. Several issues could result in the DTC P2720, primarily stemming from electrical circuit problems rather than mechanical failures. First, an electrical circuit issue can arise due to damaged wiring or poor connections, which can inhibit the solenoid from receiving the correct voltage. Open circuits, where a wire is disconnected or broken, particularly between the power source and solenoid, can also lead to insufficient input. Furthermore, a malfunctioning AT clutch pressure control solenoid D itself could be the root cause, resulting from wear and tear or manufacturing defects. Each of these potential causes should be thoroughly investigated during troubleshooting to ensure an accurate diagnosis. When DTC P2720 is present, drivers may experience several discernible symptoms. One of the primary indications is the inability to shift gears, particularly into second and fifth gears, as the fail-safe mode kicks in to prevent further transmission damage. This can make driving conditions frustrating and unsafe, as acceleration becomes uneven and difficult to control. Many drivers may also feel a delay in the responsiveness of the vehicle when attempting to accelerate, which further compounds the issues. Additionally, if the transmission remains stuck in one gear, it can lead to increased engine strain and potential long-term damage. Identifying these symptoms early is key to establishing the correct repairs and ensuring the vehicle remains in optimal driving condition. In the first step of troubleshooting DTC P2720, the technician should turn the vehicle to the on mode, allowing the electrical systems to power up. After this, use the Honda Diagnostic System, or HDS, to clear any existing DTCs, which can reset the vehicle systems and help clarify whether the issue persists. Following this, it is essential to check for both pending DTCs and confirmed DTCs using the HDS. The outcome at this stage will guide the technician in determining what actions to take next. If DTC P2720 reappears, proceed to troubleshoot further, as this indicates a consistent issue. If it doesn't, the problem might be intermittent, and may require a more detailed inspection of electrical connections related to the solenoid and the PCM. Moving to the second troubleshooting step for DTC P2720, the technician needs to turn the vehicle to the off-lock mode first. After that, checking fuse number C31, which is rated at 7.5 amperes and located in the underdash fuse/relay box, is crucial. If the fuse is found to be functional, the technician should proceed to the next step. However, if the fuse is blown, it should be replaced with a new one, and then the system should be rechecked. If the newly installed fuse blows again, further investigation is needed to identify any potential short-circuit issues affecting the fuse circuit, which will involve tracing wiring continuity and checking for ground faults. A proper diagnosis at this step can prevent further complications down the line. In the third troubleshooting step for DTC P2720, begin by disconnecting the PCM connector A, specifically the 51P connector. After this disconnection, the vehicle should be turned to the on mode, allowing voltage measurements to be taken. Measure the voltage between test points 1 and 2, with test point 1 being at PCM connector A, 51P number 1, and test point 2 attached to body ground. If battery voltage is present, it indicates that the IG1VB sol wire is functional, which confirms that the signaling from the PCM to the solenoid is intact. If no battery voltage is detected, it is critical to repair the open in the IG1VB sol wire, which connects the PCM to fuse number C31, as this can directly affect the operation of the solenoid and cause the DTC to trigger. Through the fourth troubleshooting step for DTC P2720, re-establish the connection to PCM connector A, 51P, after completing prior checks. Then, disconnect PCM connector B, also 51P, which is necessary for continuity testing. With the vehicle in the off-lock mode, continuity should be checked between test points 1 and 2, where test point 1 corresponds to PCM connector B, 51P, number 9, and test point 2 is grounded to body ground. A successful continuity test means the wiring is intact and functional, allowing the necessary signals to pass through. If continuity is not present, this indicates that the wiring or connectors may have faults, requiring further inspection to identify any breaks or damages within those lines. During the fifth step of troubleshooting DTC P2720, the focus shifts to the AT clutch pressure control solenoid valve D. Begin by disconnecting the AT clutch pressure control solenoid valve D 2P connector to prepare for continuity testing. With the vehicle still off-lock, continuity must be checked between test points 1 and 2. Test point 1 is located at the number 2 terminal of the AT clutch pressure control solenoid D 2P connector, while test point 2 is grounded to body ground. If continuity is present, the system is functioning correctly, but if not, it indicates a potential short to ground in the LSD wire that connects the solenoid to the PCM. Repairing the wire is essential to restore proper signaling and functionality. In the sixth troubleshooting step for DTC P2720, maintain the disconnection of the AT clutch pressure control solenoid valve D 2P connector, while also keeping PCM connector B disconnected. Continuity testing needs to be performed between test points 1 and 2 again, with test point 1 being the number 2 terminal of the AT clutch pressure control solenoid valve D, and test point 2 located at the number 9 terminal of the PCM connector B. If continuity is found, it confirms that the LSD wire is functional and not contributing to the DTC. However, if no continuity is detected, this suggests an open circuit exists in the LSD wire, which will need to be repaired to restore proper operation of the solenoid and prevent future DTCs. Continuing to the 7th troubleshooting step for DTC P2720, focus on the LSD-PG line. Verify continuity between test points 1 and 2, where test point 1 is positioned at the number 1 terminal of the AT clutch pressure control solenoid valve D2P connector, and test point 2 is connected to body ground. If continuity is confirmed, this indicates that the LSD-PG wire is functioning properly, allowing signals to pass through effectively. Conversely, if there is no continuity present, it suggests an open circuit in the LSD-PG wire, or it may indicate a poor ground connection at point G101. Repairing this wiring or securing the ground connection is essential to mitigate the issues indicated by DTC P2720, as it can lead to improper function of the solenoid. In the final troubleshooting step for DTC P2720, the focus is on measuring the resistance of the AT clutch pressure control solenoid valve D. After ensuring the vehicle is in the off-lock mode, and both the solenoid connector and PCM connector B are disconnected, resistance should be measured between test points 1 and 2. These points correspond to the number 1 and number 2 terminals of the AT clutch pressure control solenoid valve D 2P connector. The reading should be between 4.7 and 5.9 ohms for the solenoid to be considered functional. If the resistance falls within this range, it suggests that the solenoid is operational, necessitating a further examination of the PCM for faults. However, if the resistance is outside this range, the solenoid is deemed faulty, requiring replacement of the secondary valve body. To resolve the issues posed by DTC P2720, after completing all necessary repairs related to DTC P2720, it is crucial to conduct a final verification of repairs. Start by clearing any DTCs stored in the system, using the Honda Diagnostic System, HDS, to reset the vehicle's computer. Next, it is essential to take the vehicle for a thorough test drive under varied conditions to ensure that the repairs made were effective. During the test drive, closely monitor the vehicle's performance, particularly focusing on the gear shifting behavior. Confirm that the transmission shifts smoothly into all intended gears without delays or slipping. Performing this verification step ensures that the issue leading to DTC P2720 has been adequately addressed while providing peace of mind to the vehicle owner. To avoid future occurrences of DTC P2720, implementing a preventive maintenance routine is essential. Start by regularly inspecting the wiring and connectors associated with the AT clutch pressure control solenoid valve D for signs of wear, corrosion, or damage, which can lead to electrical issues. Alongside wiring checks, routinely examine electrical connections to ensure they are tight and free from dirt or corrosion. Maintaining clean and intact connections will help improve the system's reliability. Additionally, servicing the transmission fluid at recommended intervals can help maintain overall transmission health, ensuring that all components, including solenoids, operate effectively. By adopting these practices, vehicle owners can reduce the likelihood of encountering similar issues in the future. In conclusion, DTC P2720 serves as a vital indicator of electrical issues affecting the AT clutch pressure control solenoid valve D. Understanding that this code is rooted in an electrical fault rather than mechanical failure guides technicians in their approach to diagnose and resolve the problem efficiently. Given the critical role of the solenoid in managing gear shifts, addressing any faults quickly is crucial for maintaining vehicle performance. Thorough troubleshooting steps must be conducted to identify the root cause of the DTC, ensuring accurate repairs. By following the outlined diagnostic and repair processes, technicians can help ensure the longevity and reliability of the Honda Pilot's transmission system. Please like and subscribe to the channel. See you next time.